Good afternoon, everyone. Today we will be talking about section 4 of chapter 6, and what we're trying to do is find an easier way to show that triangles are similar. What I teach you today will only apply to triangles. It will not apply to quadrilaterals, rectangles, pentagons, hexagons, but we can prove triangles similar by knowing only two angles matching up to two angles. And that's the first postulate, the angle-angle similarity postulate. I know back in chapter, I think it was 4, I said angle, angle, angle didn't work to show that it's congruent. However, angle, angle, angle does work to show that triangles are similar. If I have three angles matching up to three angles, they could be different size, but they do at least have to be similar for triangles. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So in my picture here, I have angle A and angle D being congruent. I also have angle B and angle E being congruent. That means just by knowing that much, I can say triangle ABC is similar to triangle DEF. And that's the basic ideal of what I have covered today. Two triangles can be shown similar by having two angles match up to two angles. So what if I gave you a problem like this? Determine whether the pair of shapes are similar. If so, write a similarity statement. So what I'm going to do for each of these is I'm going to try to show that, at least for triangles, two angles of a triangle matching up to two angles of a triangle causes them to be similar. So this is the information I have. Well, this first one, they tell me that they want this small triangle here, triangle ABE and triangle ACD. Well, I'm going to separate them so that way I can see them a little bit easier. Now I know that this angle here is 46, and I know that this one over here is 45, and I just so happen to know that angle A and both of these triangles are congruent because it's the same exact angle, reflexive property. I have one angle matching up and I have the other angle not matching up. In fact, me knowing that those two angles don't match up, I can automatically say these triangles are not similar. Angle, angle failed, therefore these two shapes are not similar. The next one, number 2 up here, this angle A matches up to angle E, angle D matches up to angle H, two angles matching up to two angles. Angle-angle similarity postulate. I think it might work here, except for one problem. Angle-angle similarity postulate only works for triangles. This is quadrilateral. I don't even know if it's a rectangle. If it is, it's possible, but there's no way to tell for sure if these are similar. So I look at this, and even though I want to say similar, this one would also be a not similar. So, angle, angle, two angles have to match up. But it has to be for triangles. It doesn't work for other shapes. Alright, last try to get one that actually works. I know angle E and angle C match up. Awesome. And do I know angle A and angle D? I don't think I can say anything off the top of my head. I think there is a way that I could argue that they are congruent, but there's a lot easier of an angle to say. And that's this one here compared to this one here. Because those two angles are across each other at an intersection, these two angles are vertical angles and therefore have to be congruent because all vertical angles are congruent. So these two shapes are similar, and the order I'm going to go here is triangle blank similar to triangle blank. The first triangle, it doesn't matter what order, so I'm just going to go A, B, E. But the second triangle, it does matter immensely on the order because it has to be the same exact order. So I go from this angle to here to this angle to here. So I went A, B, E. So if I look at the marks, no mark to two marks to one mark. So the only mark I have is D here. So A and D match up. Now I have to go to two marks. So I would go toward B. And then last but not least, I have to go towards C. Quick check. Angle A and angle D, are they congruent? They will be. Angle B and angle B? They are. Angle E and angle C? Yep, they are. So, these two triangles are similar, and this is their similarity statement. And it matches up. So, two angles is enough in a triangle to say they are similar. Boom. If they don't match up, automatically not similar. And if I tried for a shape other than a triangle, I cannot say if it's similar or not. In fact, I probably should have put not enough information here instead of not similar. And there we go. This is how you would do the first example. The second example, I'm just going to say, show that these two triangles are congruent, and write a proportionality statement and a similarity statement and a statement of proportionality. I actually messed up a little bit here. I didn't remember to say that segment KN and segment LM are parallel. So, mark those please. This is what you were supposed to have. I forgot these marks here to say that they are parallel. Now it says show these two triangles are congruent. So it's not a proof. It would have said prove these two triangles are congruent. It just says show. So I have to make a reasonable argument that these two are parallel. Sorry, that these two are similar. So I look. The two triangles I'm talking about, I'm going to redraw them. It's these two. If I look, angle J is the same angle for both. So I think reasonably speaking, I could say angle J is congruent to angle J. And I could give a reason. Might as well. It's a reflexive property. But the other two, I need to get one more pair. Either angle N and angle M, angle K and angle L. Oh wait, parallel lines. And I'm talking about angles. So what I'm trying to do here is I'm trying to remember all the way back to chapter 3, and I want to know about corresponding angles, alternate interior angles, alternate exterior angles. If I know something about that, like if I get them paired to match up, I get angles that have to be congruent because the lines are parallel. So if I look, angle L and angle K are both on this transversal line JL. They are in the upper right of both intersections. In the upper right of this intersection and in the upper right of this intersection. Therefore, they are in the same location of my parallel lines and on the same side of the transversal. So they are in the same corresponding angle location. So angle K in this case and angle L have to be the same. I have to be a little bit careful with this name though. So angle JKN is congruent to angle L. This one has to be 3 because there's 3 letters long because there's 3 possible angles. And this one would be CA postulate. The parallel lines cause the corresponding angles to be congruent. So I have 2 angles matching up to 2 angles. Triangle JKN is similar to triangle JLM. Angle, angle. I have shown beyond any reasonable doubt that these 2 triangles are similar because they have 2 corresponding angles being congruent. The last thing I have to do is write a statement of proportionality. Using this, I know my statement of proportionality will look like this. First 2 letters, JK. Next 2 letters, KN. First and last letter, JN. Do the same thing over here. JL is the first 2 letters, LM is the next 2 letters, and JM are the outside. This is my statement of proportionality. This is my similarity statement. And I have shown beyond a reasonable shadow of doubt that these 2 triangles are similar. One thing that you're going to need to do in your homework is you will have to remember these parallel lines and the angles that form them. You will be using alternate interior, you'll be using corresponding angles to show that angles match up here, that they are congruent. Okay, so the main part of your homework will be, are these triangles similar? Show it, determine, that sort of thing. But the other part is, hey, let's try and use this somewhere. If I know 2 triangles are similar, and I know 1 or 2 or 3 side lengths, I can measure something without having to physically measure it. Like, for instance, what if I want to know the height of a flagpole? I don't actually have to have somebody standing near the top or having some way to have a tape measure put up to the top. All I have to use is a similar triangle. Maybe I'm going to use the shadow of a person standing by it and the shadow of the flagpole, and I can measure the shadows and the height of me, and I can form a triangle there. It might be I'm trying to find the height of a building. It might be I'm trying to find the distance across the river. It might be that I'm trying to figure out something on the astronomical scale, like how far the sun is from the earth. But in all those cases, what I'm almost for sure going to do is I'm going to set up 2 triangles and figure out if they are similar. So this picture right here, I drew two triangles. Alright, in this example here in the picture, I drew two triangles. I told you 3 pieces of information about them, like this. And I could find the unknown length. I can look at this picture and say, oh, this triangle and this triangle have to be similar. Angle, 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 similarity postulate. So therefore, their corresponding sides have to match up. X to 2 meters equals 15 to 3. Those are its corresponding sides because they match up in their corresponding location. Both of these are legs. This side is across from the congruent angle I know of. So x to 2 matches up to 15 to 3. Now all I have to do is cross multiply and solve, and I will get 6 equals 30. Sorry, 3x equals 30, and x therefore is 10 meters. I found a length indirectly without actually having to physically measure it. Now yeah, I could maybe use a ruler there and measure it and figure out if it was actually 10. But that's the whole point of this, is so I can find measurements indirectly without actually having to measure them. So, what if in this example here, I give you a picture, and I say, find the value of x. Well, let me write down both of these problems. What if I've measured this stuff out here, and I want to know what x is? There's actually one piece of information I forgot again. I forgot to label that these are parallel. Well, if they are parallel, just like before, angle A is congruent to itself, and this angle over here is going to be congruent to this angle here because they're corresponding angles. I'm going to redraw both triangles, ABE, and triangle ACD. Now the reason I'm doing that in this case is because you could get this wrong very easily. The length of AE is easily known to be 5, and the length of the segment BE is x. However, what's the length of segment AD? It's not 5, it's not 15, it's 5 plus 15. It's the full length, 20. The bottom here is not 26, it's 24. So that's 24. Now look, if these are the two triangles that are similar, which they are, then the proportion I'm going to set up will be the corresponding one. So I look, 5 to 20 has to equal x to 24. I now have a proportion in which I could solve for x. I'll cross multiply, I get 20x to be 120. Divide both sides by 20, I get x to be 6. I just found a length indirectly without having to measure it. That's the whole point of this. Let's look at the word problem. It says, a flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby, who is 5 feet 4 inches tall, casts a shadow that is 40 inches long. If the height of the flagpole is x, what is the value of x? Well, if I drew this here is my flagpole. This is the shadow of my flagpole. I don't know the height of my flagpole, but I know the shadow is 50 feet. Now, there's a woman standing here, for lack of my artistic skills, I'm just going to draw her this way, is 5 feet 4 inches tall. 5 feet, that's 60 inches. So 60 inches plus 4 inches is 64 inches. So I'm going to just convert it into one number set here. She's 64 inches tall. Her shadow is 40 inches long. This doesn't look like a triangle until I connect the tip of the shadow to the tip of the flagpole. Tip of the shadow, tip of the shadow to the tip of the head of the person. This is a right angle. They're standing straight up. If it's from the sun, this angle and this angle should match up because the sun is in the same angle in the sky to both the flagpole and the woman. I look. Two angles match up. These triangles are similar. And I know 3 lengths, and they are in the corresponding locations. I should be able to find x pretty straightforward here. Pretty easily, in fact. I'm going to compare 50 to 40. 50 feet to 40 inches. And I'm also going to compare x to 64 inches. If these are similar triangles, which they have to be, this proportion has to be true. At this point, I'm going to switch the means location, so I get 50 feet over 40 inches. Over x equals 40 inches over 64 inches. Inches will cancel out, and now all I have to do here is cross multiply. 40x equals 23,200. Divide both sides by 40. X is 80 feet. And there we go. Basically, what you're trying to do in this section is show triangles are similar by angle, angle. And then you're trying to set up the correct proportion using the idea that, hey, these triangles are similar, so that means their sides are proportional. It's not really anything new. It's just a shortcut. Angle, angle. That's all I have for you. Till next time.